Alright, this is our video for lesson 11 for AP Calculus. This is when we're going to start talking about some applications of the derivative, specifically in terms of particle motion. So this will line up nicely with some of your experiences in physics, and for some of you maybe hopefully make some of the things you did in physics a little clearer. So we can measure the position of a particular item using a function, and we're going to do that using the function s of t, where t is a value of time, and then s of t is either the height or the position. We are talking about motion of a particle either in a horizontal fashion or a vertical fashion. So our new position relative to the starting point is going to be identified by a spot either horizontally or vertically from our starting. If I want to measure how that position is changing, measuring what's called the velocity will measure the change in the position, the instantaneous change in position at any given time. The instantaneous rate of change in the position at any given time. Now, velocity is not the same thing as speed, even though we do use those words in the world as synonyms. In the physics world, velocity and speed are two distinct things. When we are talking about a velocity, we have a numeric value associated to it and a sign value associated with it. The sign is not indication of the size. Sign is indication of direction of movement. So velocity, a positive velocity is indicating we're moving, and if we're talking about these two limited trajectories of movement, moving either to the right or up, and a negative velocity is an indicator that our particle is moving, our item is moving to the left or down. Okay. Velocity is a vector quantity, which is the fancy way to say that the number associated is a size, the sign associated with it is a direction. It's the same concept as a 30-degree angle of rotation versus a negative 30-degree angle of rotation. The negative 30 angle is not smaller, it is just directionally different. Okay, 30 degrees is measurement in the counterclockwise direction from what we call the zero axis, and negative 30 is in the opposite direction. If we look at just the absolute value of the velocity, so we basically are just looking at the magnitude aspect and ignoring the sign, that in fact is called speed. Okay. That becomes important because when we look at velocity values, when we have a -5 velocity and a -3 velocity, speed-wise, a -5 velocity represents a greater rate of speed than a -3 velocity. Because in speed, always looking at the absolute value. So if I have a position function, if I have a function that describes an item's position, by taking the derivative of that function, I can measure the velocity of that particular item at any point in time. If I then take the second derivative, or the derivative of the velocity function, okay, or the second derivative of the position function, I will get the acceleration. And this acceleration is going to measure the rate of change in velocity. Okay. The sign of acceleration is going to indicate how the velocity is changing. So when the acceleration is positive, my velocity is increasing. When my acceleration is negative, my velocity is decreasing. If I want to actually discuss speed, not velocity, but speed, and how speed is changing, I have to consider both the velocity and the acceleration. When the velocity and the acceleration are working together, have the same sign, a positive velocity with a positive acceleration, or a negative velocity and a negative acceleration, same sign means our speed is increasing, or we will talk a lot about things speeding up. When our velocity and our acceleration are working opposite of each other, where we have our velocity going in one direction, but the acceleration is going against that, so a positive velocity but a negative acceleration, or a negative velocity with a positive acceleration. Different signs means the speed is decreasing, or we're slowing down. The mistake we often make here is trying to put our experiences with a car and connect it to this. In a car, we're not talking about velocity, we're talking about speed all the time. Okay? Velocity is going to be important to talk about in a theoretical concept, movement in an opposite direction. As we think about how we measure what's going on with a car, this kind of stuff doesn't really apply so much. It's a little harder to reconcile because you think, well, you know, to actually have a negative velocity situation, we almost can't represent that with what we typically, at least I have a hard time figuring out matching that with what I know about motion as, you know, when I think about acceleration, I think about a motor vehicle. So let's remember, we're talking about theoretical particle movement, side to side movement, or up and down movement. If the velocity says one thing and the acceleration says something else, if we have a -2 velocity, -2 feet per second, but my acceleration is 3 feet per second squared, that's a decreasing speed situation. We will look at that in more detail with some more specific data so you can kind of try to reconcile that a little bit more. If you are having a hard time wrapping your head around it, this might start as a memorizing thing. Okay. The last concept, displacement. We're actually not going to do very much displacement yet, but displacement is change in position from one point to another. So the position at time B minus the position at time A is a displacement. All right. So, a question like this. Different things we can do given this particular position function. Also, we need to kind of make clear here, we're often going to be given some kind of clarification that we are talking about time, and our time measurements would be either greater than 0 or greater than or equal to 0. Position of the object at 1 second would be s of 1. And s of 1 means we're going to just plug 1 into our position function. 1 minus 6 plus 9 equals 4. So we're 4 meters from the starting point. From the start, wherever that is. What is the velocity of the object at 2 seconds? Well, the first thing I have to do there is write my velocity function. If my position function is given by that cubic, my velocity is going to be the derivative of that position, 3t squared minus 6t plus 9. Oops, not plus minus 6t. Nice that I make as many mistakes in video. And so then velocity at 2 is going to be 3 times 2 squared minus 12 times 2 plus 9. So 12 minus 24 plus 9, negative 3. And velocity is the slope, rate of change of position. Position is measured in where the x, or t, is seconds, and the y is in meters. So the inputs are seconds and the outputs are meters. So this is negative 3 meters per second. Speed would be the absolute value of the velocity at 2 seconds. So that would be positive 3 meters per second. The acceleration function is the derivative of the velocity for the second derivative of the position. In this case, that takes me to 6t minus 12. So my acceleration at time 5 is going to be 6 times 5, oops, sorry, 6 times 5 minus 12, 18. And it is how the velocity is changing per second. So it is 18 meters per second, or 18 meters per second squared. We're looking at how the velocity value is changing with respect to time. Velocity values are in meters per second. So this 18 means meters per second squared. That means my velocity is definitely increasing at t equals 5 seconds. But whether the speed is increasing or decreasing, we would have to see the speed at 5 seconds. Sign of the acceleration tells you if velocity is increasing or decreasing. The acceleration sign and the velocity sign together is what you need to determine speeding up or slowing down. And then displacement would be position at 5 minus position at 2. And I'm going to be very honest and say, yuck, I don't really feel like doing that right now. Oops. Squared. Oops, I don't know what the heck's going on here. Cubed minus 6 times 5 squared. So this is 20 minus 8 minus equals to 18 meters. Double check that. Displacement is actually something more we'll talk about when we get to the second half of particle motion, which is looking more at the position displacement versus total distance. What am I looking at? I'm looking at the table. All right, so let me see here. 5 is 20 and 2 is 2. Okay, good. Just had to double check myself. All right, great. Those are the basics for part 1 of lesson 11.